All right, so in 4.3, this is our no calculator section. We're doing operations with polynomials. And the operations we're going to focus on are adding, subtracting, and multiplying. So this is going to be a no calculator section. Okay, so a monomial is just one term. A binomial is two terms. And a trinomial, three terms. A polynomial is going to be a monomial itself, or it can be a sum of monomials. Okay, so it's either a monomial or a sum of your monomials. Okay, and we are adding, subtracting, and multiplying today. So if you have one term, it could look something like this. 1/5 x to the 4. If you have two terms, an example would be 2x to the 5th minus 3x. So they don't always have to go in decreasing order. Or a trinomial, we've been working with trinomials a lot when we've been working with quadratics. So x squared minus 3x plus 2. So really, what separates the terms in a polynomial? Not the exponent. Yeah, so the minus sign or the plus sign. Yep. And then you can have like they can be multiplied by something there. So in example 1, we have to determine whether each expression is a polynomial, and then if it is, we're going to state the degree. So the first thing is to determine whether it's a polynomial, and then if it is, then we're going to state the degree. So let's remember from the other day, things that polynomials should have here. Or can't have, really. That's going to be easier. What was one of the things that you have to have for it to be a polynomial? What are things we found in like our homework, and we said it's not a polynomial because... Yep, good. Okay, so you can't have any negative exponents, so that happens when there's an exponent in the denominator. So no negative exponents. What are some other no-nos? Should we get out our notes and look, or you be able to come up with some with your rope? You won't have that, that'll be in your regression. So yeah, when you have a polynomial, often you won't have your values A being 0, but we're looking for something else. Yeah, Yep, so you only want one variable. We are going to have some that have a couple. We were talking about polynomials and one variable in that first section, and most of your polynomials are going to have that. What else? There's something else with our exponents. Yep, so that's the negative one. Yep, because if it's in the denominator, it'll be negative. The other one has to deal with fractional exponents. So no negative exponents, no fractional exponents, and you also can't have any square roots or really any type of radical, okay, with a variable underneath it. Okay, so you can't do like a square root with a variable in it. Okay, and then for A, we have the square root of x squared plus x plus 2. So right away, we know there's a problem because we just talked about this. It's not a polynomial because what can't you have? The square root. Okay, so not a polynomial. And we're going to be specific and say because you can't have the variables under the radical. And the reason why I say radical and not just square root is because you could have a cube root, you could have a fourth root. We haven't really done a lot with those yet. Okay, but I wouldn't mark it wrong if you said square root because this is a square root. Okay? All right, and then for B, you have m to the 5th minus 3/4, and then it's m to the 7th. So that placement of m to the 7th is important. When you have it off to the side like this, it is not a negative exponent, so this is a polynomial. So yes, it's a polynomial. And what would the degree be? 7. Okay, so the degree is always the highest exponent. Now, if you had, we're going to call this an FYI, okay? If you had m to the 5th minus 3/4m to the 7th, this would not be a polynomial. So if you have m to the 5th minus 3/4m to the 7th, okay, then it's not a polynomial. Because m to the 7th can't be in the denominator. Okay, so if the variable is in the denominator, that can't happen. That's a negative exponent. But if it's on the side or if it's in the numerator, that is okay. And yeah.
Why is it that an exponent of the in the denominator?
That's your rule. That's one of your rules that we wrote out. Remember, if you have x to the negative n, the way to simplify it is, oops, I wanted to use, I want to use the same things. So if you have x to the negative n, the way that you can rewrite it is you can write it as x to the nth power. Okay, we can check this too when we plug in certain values. For example, if you have like 10 to the negative 1st, that would be 1/10 to the 1st power, or 1/10. That's something that you can check really easily on your calculator. If you do 10 to the power of -1, see how you get 0.1, same thing as a 10th. Okay. All right, and then for part C, you have 6ab squared over c. Okay, and again, you have this variable in the denominator, so you can't have that for a polynomial. So it's not a polynomial because you can't have c in the denominator. Okay, so not a polynomial because you can't have c in the denominator. We are going to be working with some of them that have those. There's polynomials in one variable. There's also polynomials in different variables. So for this section, we're just going to focus on these rules here. The no negative, the no fractional, the no square root. Okay. All right, and then for examples 2 and 3, we are going to add or subtract. This is going to go very well for you, I anticipate. And we're going to be writing the answer in standard form. So when you are adding your like terms, you guys have done this before, and often people use like similar underlining techniques to combine those together. So if you guys want to do that for part A, underline your like terms, we can do that. Okay, so you can use whatever strategy you like. Okay, so I like to use the grouping symbols. I feel like that just helps me. So when I'm underlining, I underline them the same, and then you're going to add the coefficients together. Okay, and then if you don't have anything to add it to, like 5x squared, that's the only one. So I'm going to keep that. And then you have the negative x and the 7x, which will produce 6x. And then your number is 9 and 4, which is going to give you 13. Right, now when you have subtraction, you have to remember to distribute the negative. So I'm a visual person and I like to write out what the distribution is going to be. Some of you may be very comfortable and very good with not writing it out and just doing that part in your head, and that's fine. Okay, so for me, I like to distribute and then I can look exactly what I have. So I have negative 2x squared and negative x squared, which will give me negative 3x squared. There's nothing else to combine with the x, so I'm going to add that. And then I have a negative 6 and a positive 3. So 3 minus 6 is going to give you what? What's 3 minus 6 going to give you? Negative 3. So then this is going to be your final answer. Okay, so I want you to decide how you want to approach the subtraction, and I want you to try that for part C, and then we'll check our answers together, okay? Yep. All right, and then go ahead and check your answer with mine. So I distributed my negative, combine my like terms, no like terms for 5y cubed and 2y. But negative 2 minus 1 gave us negative 3y squared, and then negative 1 plus 3 gave us 2. How'd we do? Good. Okay. So like I said, if you want to do the minus yourself, that's fine. Just remember, if you have minus and negative, it does turn into a positive there. All right, now we get to multiply. So when you multiply, you are really doing some type of distribution, and that could be something that's FOIL. When you're writing it in standard form, the standard form is only going to apply if you have more than 2 variables. Okay, so if you have more than 2, there's no standard form required. Okay, so if you have more than 2 variables, you don't have to worry about standard form. So some of them we're not going to have to worry about. remember the rule when you are multiplying something with the same base. So when you're multiplying these together, you have 4y squared times y squared. When you multiply something with the same base, do you guys remember what you do to the exponents? You add them. So this is like y to the 2 plus 2. Okay, so you have to add the exponents. When you're multiplying, you add your exponents. We are going to talk more about these type of rules later on in the semester. So I always tell myself you multiply number by number. So 4 times 1 is 4. Y squared times y squared is y to the 4th. Then we do the same thing here. So 4 times 3 is 12. There's nothing to multiply the y squared by, so it's going to stay y squared. And that's your final answer. Okay, now for B, this is one that people commonly get wrong because they distribute the square. But remember, we did a lot of work with our perfect square trinomials. Remember how this is a perfect square trinomial? Like what we did with completing the square? So this really means 3r minus 7 times 3r minus 7. So we can expand this using FOIL. Or if you remember your perfect square trinomial pattern, you can do that too. Right? So what's 3r times 3r? 9r squared. And then don't forget here, this middle value and this outside value are going to double. It's a negative 21r minus 21r. So your total in the center is what? Negative 42r. And then a negative times a negative is a positive. So anytime you have something squared, your result should be that perfect square trinomial. Okay, every single time. The only type of patterns that are going to create the difference of two squares are when you have like 3r plus 7 and 3r minus 7. Okay, so if it's squared, you have to have that trinomial. Okay, now for ones like this, do you see how this isn't in standard form here? You don't have to put it in standard form at this point, but I think it's a little bit easier. Okay, so if you want to write this in standard form, you'd have a minus 3 times a squared minus 5a plus 2. And I think it makes it a little bit easier. If you don't do it now, you're going to have to do it at the end. So either way is fine. And then what you do is you multiply or you distribute a to everything in the parentheses. So a times a squared is a cubed. A times negative 5a is negative 5a squared. And then a times 2 is 2a. Now you have to distribute everything with the negative 3. So negative 3 times a squared is negative 3a squared. I like to line up my like terms together. If you like to make the big line, that's fine too. Both of those are going to work. And then a negative times a negative is going to turn into a positive. So negative 3 times negative 5 is 15. And then you have the a with it. And then negative 3 times 2 is going to be negative 6. And I like this because now I can just add straight down. And I have it in standard form. So you have a cubed minus 8a squared. Negative 5 minus 3 is negative 8. 2 plus 15 is going to give you 17a. Okay, so again, just make sure that your final equation is in standard form. Okay, if you did this like the way that it's shown here, you could do that as well. It's just it would be written backwards, and then you would write it in standard form. Okay, so you have to do it either at the beginning or at the end, okay? All right, now for part D, we have 3 binomials. So we're going to have to do FOIL first. So you can pick which 2 you want to FOIL. I would pick the ones that have the same variables because it's going to be a little bit easier. So your first step is to pick 2 binomials to FOIL. Okay, and then if you can, do the same variables first. So this one has A and B, this one has A and B, this one has C and D. So if I choose the ones with both A and B, we're going to FOIL those. When you multiply, you want to make sure you put them in alphabetical order. So we'll do this first one together so you can see what I mean. When you do 4A times A, you get 4A squared. When you multiply here, if you multiply B times A, if you put it in alphabetical order, it's just A times B. Okay, so that's the inside. Now I'm going to do the outside. So 4 times negative 2, negative 8, A times B, AB. B times negative 2B is negative 2B squared. Okay, so we FOILed those together, okay? Now we're going to combine the like terms. So I have a positive AB and a negative 8AB. So that's going to be negative 7AB. I'm going to keep this inside the parentheses. And then this guy is going to come and join the party. So your first step is picking the two binomials to FOIL. We did the same variables first. Now we're going to distribute. Okay, and there is a no standard form because you have more than two variables. Okay, so when I distribute, I always take the smaller one and distribute it to the larger one. That's just quicker for me. You can do what you would like. So if we multiply 3c times 4a squared, again we do number times number. So 4 times 3, and we're going to need some space for this, so I'm going to put this here. So 12a squared c, 3 times negative 7 is negative 21, and then see how it's ab times c, so it's just abc. Okay, and then here I'd have negative 6, and then it's b squared c. And now we're going to distribute negative d to everything. Okay, so I'll give you a minute to do that, to multiply them all. Multiply negative d by everything in the value behind it. So when you multiply negative d by 4a squared, it'll be negative 4a squared d. And then a negative 1 times a negative 7 is going to be plus 7 abd. And then negative d times negative 2b squared is going to be plus 2b squared d. Okay, so you have a squared c, no other of those, no other abc's, no b squared c's, no a squared d's, or abd's, or 2b squared d. So this is your final answer. Okay, and whatever order you multiply that in, it's fine. So there's no standard form for this. Okay, there's only standard form if you have two variables or less. E, and we're actually going to move F down. So I'm going to show you another way that you can write this out. So in this one, we just like did the distribution. When these are written down in your textbook, another way to help you, like just visually, because our vision is what sometimes makes those careless mistakes. So instead of writing down that I'm like multiplying everything by 2c, another way you can think of it is you're multiplying the 5c to the 5th plus 2c squared minus 8c plus 4. That's what you're multiplying together. So when this is in your textbook, instead of like looking back and forth to your textbook, you can write it down on your paper. And I found that this helps students organize that better. Kind of helps with some of those smaller mistakes that we make. Because we're going to multiply everything by 2c and then everything by -3. And again, don't worry about going into F's space. That's what we're going to do. Okay, so if you multiply everything by 2c, multiply number by number, so you have 10c to the 6th plus 4c to the 3rd minus 16c squared. 2 times -8 is -16. C times c is c squared. 4 times 2c is 8c. And then I'm going to give you a minute to do these, but when you do them, I want you to line them up with their like terms. So if you do -3 times 5, and you can see it's c to the 5th, I'm going to put it right here in between the 6th and the 3rd. And then if I have like terms, I'm just going to stack them on top of each other. Okay, so this one's going to be c squared, so you're going to put it under the c squared. Okay, and then I just want you to add your like terms together, straight down. All right, and then when you are adding straight down, you're switching gears a little bit because you just went from multiplying to adding. So nothing else is lining up with the c to the 5th or the 6th or the 3rd. So all of those just drop straight down. When you have two negatives, you add them together. So 16 and 6 is going to make what? 22. Good. 24 and 8. Nope. If you subtracted. Did you subtract it? Add it together. Yep. I try to count up to 30. Like you'll need 6 to get to 30, so it'll be 32. And then minus 12. Okay, and then that is going to be your final answer, and that's in standard form for you. Okay, so for F, you have a trinomial times a trinomial. Again, you can use the distributive method, like the y squared multiplied by everything, then the -7y. Okay, you can also just line up if you have y squared -7y plus 5. You can just line that up here, and you're multiplying it by the y squared minus y minus 3. And again, if you're doing this from your textbook, that just helps you line everything up. Okay, so I'll give you a minute to multiply those, and we'll check them together. All right, how do we think we did on this? On the last one. I like it when they all line up nicely like this because you have y to the fourth minus y cubed minus 3y squared. And then this one, you're going to start here. So it's negative 7y cubed plus 7y squared plus 21y. And then this one will be 5y squared. So you would line it up here. Minus 5y minus 15. And then you can just add straight down, and it's so nice. So y to the fourth minus 8y cubed. 12 minus 3 is going to give you 9y squared. 21 minus 5 is going to give you 16. And it's nicely in standard form for you. All right, and then I'm going to put up your homework problems for today. I think there's a total of 15. Whenever I give you ones that are evens, guys, it'll start with an even and it will end with an even.